don't know what the conversion rate is. It's,
There is a conversion, like a sort of equation you can find online. Yeah. I don't know the trend, like the transformation behind as well, because I'm not like 100% wing expert as well.
no, that's okay.
Yeah.
I just wanted to get a sense of like how windy is 20 meters per second. It's
Yeah.
really windy.
It's really windy.
You wouldn't be standing up hardly.
No.
You'd be, your umbrella would be blown inside out.
Exactly. Yeah. But still, if you measure at like 10-meter height, you might still get these occasionally.
Yeah.
Yeah. But that will highly depends on what was which side.
Why is it measured at 10 meters?
Oh, this is just like a standard thing.
Mm-hmm.
Yeah. So the whole industry would do that. We based on we would use the unit based on this one.
Mm-hmm.
Measure at 10-meter, 30-second gust. But in for example, in our demo here, or in any of the solar farm, they only measure at 4-meter.
Mm-hmm.
And what we actually use is a 30 seconds like a gust.
Mm-hmm.
So you will have to do some transformation because it's slightly different from this one, different height, different interval. So there is like an equation you were going to use to transform between different like time interval and height.
Yeah, cool.
All right, so yep, let's look at the wing speed profile for this particular site. So this is the distribution of the hourly average wing speed. Yeah, so because that's the wing speed data that we can access so far. So as you can see that the high wing speed situation are kind of like occasional. Yeah, they don't happen like very often. So most are right under in the middle left here. They are like a kind of low wing speed. But still, if we place the like the wing speed threshold onto that curve.
Wow.
Yeah.
You can see how much stowage is occurring.
That's correct, yes. So here I would like to explain a little bit further more about the wing speed transformation, because we tag them as like the 3-second gust 10-meter height wing speed, but we are actually using the 1 hour average. So there is like a transformation between them. So the transformation we use is called the dust curve. So the dust curve you would probably have like a lower number of the average hour, but it's actually equivalent to the high number in the 3-second. Yeah. So just give you some idea about this. But no matter, and as you can see anyway, on the right hand, like the color of the stow hours in total and the stow time per year, obviously you will have a lot more stow position with the lower stow wing speed threshold.
So I can see like typically 14 to 16 meters per second for most trackers, conventional single point trackers, are getting somewhere between like 2.7 and 6.9% of the year stowage. But with the higher wind speed, 2022, we're down to less than half and less than a quarter for the SkySmart 2 and Skyline 2.
Exactly.
Wow. Yeah. So it's almost nothing. It's less than 0.25% per year lost production, or not completely lost, but reduced production due to stowage.
That's correct, yes. So this only represents the time that they went stow. That does not necessarily mean they don't produce energy, and some of those time will happen during nighttime, so it won't have like any effect. But let's pick one day.
Gee, you could put a dollar value on that too. I imagine like how much are you actually losing?
I will show soon. Yeah.
Okay.
Before that, maybe we can pick one day to explain the effect of this. So this is the curve for 7th of June. Well, I forgot to mention that all this data comes from the NREL and the MERA. NREL is like a reputable solar irradiation data producer. They measured everything using some weather station or even the satellite.
That's the National Research Energy Laboratory.
That's correct. Yes.
NREL.
Renewable, I think.
Renewable.
Yes.
National Renewable Energy Laboratory.
That's correct. Yes.
Yeah, I've used their data before. It's a great source.
That's right. Yeah, and the wing data is from MERA, MERRA, MERA 2. So they also have the 10-meter height hourly average data everywhere. So what we used is like the actual 2020. All the data come from the year 2020. So, so what you've seen here is the